This video is going to focus on the density worksheet. And density, in summary, is defined as the degree of impactness of a substance. And I'm pretty sure you guys can read this by yourself, but a key thing is the unit. The unit is usually grams over milliliter. So basically mass over volume. Okay? So, let's start with question number. Oh yeah, and also a heads up. This is our standard units for density. So keep that in mind. So let's start with question number 1. Question number 1, it says a cube of lead has a volume of 6.61 centimeters cubed and its mass is 75.0 grams. What is its density? So here, another thing, anytime you do chemistry with math chemistry problems, always remember sig fig. Okay, so this has 3 sig fig, and this number also has 3 sig fig. So, and since this, let's see if it's an addition or division and see what we need. So do you know how our standard unit for density is grams over milliliters? We are given the volume in centimeters cubed. Another key thing to remember for chemistry is that 1 milliliter is equal to 1 centimeters cubed. So they're like the same unit basically. So if I convert this 6.61 centimeters cubed, I want to put my centimeters on the cube on the bottom, my milliliter on top, cancel those out, so I get 6.61 milliliter. Okay, so let me move this over here. Okay, now we're given the volume milliliters, and now let's find the density. So we're given the grams, which is 75.0. So I know it's mass over volume. So if I put mass, the given mass here is 75.0 grams over 6.61 milliliters, I will get, let's see here, 75 divided by 6.61, 11.346 grams over milliliter. And since this is only division, division and multiplication only care about the least sig fig. So from our answer, our question, we know both number has 3 sig fig, so that means our final answer must have 3 sig fig. So if I highlight right here, that's our third, cut it off. We're going to round down because 4 is less than 5, so our final answer will be 11.3 grams over milliliter. Moving on to question number 2, it says at 25 Celsius, 1.00 centimeters cubed of iron has a mass of 7.62 grams. What is the volume of iron is occupied by 125 grams of iron? So we're trying to find the volume. Okay. So this first part gives us our density. The reason is, I know from my previous question, I informed you guys, centimeters cubed is the same thing as milliliters. I know, so in this, and then we are given our mass. So our density for this iron, of the iron at 25 Celsius, it will be 7.62 grams over 1 milliliter, which will equal to 7.62 grams over milliliter. So Now the second part of the question is asking us finding the volume of the iron occupied by 125 grams. So basically, we are given grams and we want milliliters. So 125 grams times something must give us milliliters in the end. So we are given this. We solved this in the beginning. So we gotta cancel out the grams. To do that, we put this top value in the bottom and this bottom value on the top, giving us 1 milliliter over 7.62 grams. And if I do that, I get 16.404 grams cancel out, milliliters. And since this is only division and multiplication, all the answer choice has 3 sig fig. So that our final answer should have 3 sig fig. So cut it off right here. We round down because 0 is less than 5. So our final answer here is 16.4 milliliters. And in the answer choice, it just left it as centimeters cube, and you guys can do that. So you can just leave it as 16.4 centimeters cube. Whatever is like more convenient for you guys. Now, question number 3 is saying that calculate the mass of a liquor with the density of 3.2 grams over milliliters, and the volume is 25 milliliters. So we're given the volume and we need the mass. And the units for these is milliliters to grams. So if we start with 25 milliliters, to cancel out the milliliters, we're gonna have the milliliters at the bottom. So this one already has it at the bottom, so it'd be 3.2 grams and 1 milliliter. Cancel that out, leaving us with 25 times 3.2, leaving us with 80 grams. Now, since this has 2 sig fig, we need to put a decimal right there to make that 0 a significant number. So our answer right here will be 80 grams. Or in the answer choice, it converts this into exponent. So you can write it as 8.0 times 10 to the first grams. And remember to make that 0 significant. Okay. Next question. It says an irregular object with a mass of 18 grams displays 20. So question number 4 says an irregular object with a mass of 18 kilograms displays 2.5 liters of water when placed in a large overflow container. Calculate the density of the object. So here is us using a little lab experiment. So basically, to calculate the density of something, you would just put it in water. And you will level this out, the initial, volume. And once you put the object in there, boop, the water is going to rise up. And this difference is the volume that the object takes. So knowing that, let's get the density. So we know it displaces 2.5 liters of water. That means this is our volume. And this is our mass. So since density is mass over volume, we can just plug in our known, which is 18 kilograms over 2.5 liters, which will equal to 7.2 kilograms over liter. So since both of these numbers has 2 sig fig, our final answer must have 2 sig fig. Another challenge you can do is, depending on the professor, it might be asking, oh, keep your units as grams over milliliters. To do that, I'm going to cancel out my liters by doing this, because I know 1 liter equals 1,000 milliliter. And now, in 1 gram, there's 1,000 kilograms. So I'm going to put kilograms on the bottom for 1 gram. So this cancels out and this cancels out, with having us grams at the top and milliliters at the bottom. So if I do that, I'll get 7.2. Oh, I don't have space here. 7.2, 10 to the negative 6 grams over milliliter. Okay, so this is an extra step you can do. Okay, final question is question number 5. So I don't know why it didn't get written here. So it said graduated cylinder has a mass of 80 grams when it's empty. So let's draw that out. So 80 grams. And when 20 grams of water is added, the graduated cylinder has a mass of 100. So if we add 20 milliliters, our mass is 100 grams. If a stone is added to the graduated cylinder, the water level rises 45 milliliters and the total mass now is 156 grams. What is the density of the stone? So if I draw another one, oops. Put water here and we have a stone. So our water, so it was initially 20 milliliters, but it moved up to, what was it? 45. And our mass now is 156 grams. So all we can do here, we don't have to worry about this initial change. This is just something to catch you off guard. The only thing that we have to focus the change is this. So once we add the rock, the mass changed to 56 grams. So that means this is our rock mass. And since the water level changed 25 milliliters, that's the volume of the stone. Equal volume of stone. Knowing that density is mass over volume, we found that the mass of the stone is 56 grams, and then the volume of the stone is 25 milliliters. And here, everything is, this is only 1 sig fig. But we don't care about this one. 1 sig fig, 2 sig, this is only 1. And this is 1 sig fig, 3 sig fig, and this is 2 sig fig. So when I do minus right here, right, let's make sure our sig fig is right. Minus 20. So if I put it right there, that will equal, and this is our sig fig right there, 25, and our sig fig is still right here. Don't round up yet. And then this is still 2 sig fig. So when we do this, we should get 2.24 grams over milliliters. I don't know why the answer is saying it's 2 sig fig, but I believe it is only 1, so I'm going to cut it off right here and say it's 2 grams over milliliters. And I can be wrong, so if you think I am wrong on the sig fig, please let me know. And yeah, but there we go.